30-day challenge. Welcome to day 3. Welcome to day 3 of the Jamb Master 30-day challenge. We are live again. Guys, we are making progress every day. Little by little, we are covering. Little by little, we are covering. Thank God for the momentum. We have not missed any day so far. This is very good. Thank God for the momentum. Thank God for everything that is going well. This is day 3. Welcome. As soon as you come in, I want you to say active. I want you to say active. Active, sir. If you're here with us, say active, sir. This is day 3. Day 3. Day 3. And we are kicking off immediately. No time to waste. If you can hear me, say I can hear you, sir. If you can see the board clearly, say I can see the board clearly. No time to waste. No time to waste. We are kicking it off immediately. No time to waste. You are all welcome. On the board, you can start writing down. Get your writing materials. Get your writing materials. Put your phone on Do Not Disturb and focus on the class. Get your writing materials. Put your phone on Do Not Disturb and focus on the class. Get your writing materials. Put your phone on Do Not Disturb. Tell your parents you have a serious class. Yes, this is a serious class. Make sure you are with your writing materials. Yes. Start writing what is on the board already. Start writing what is on the board already. These are the topics we are treating for day 3. Don't forget, we have the topic for every day already. We have a topic for every day already. So this is topic for day 3. We must cover this night. So we are not leaving here this night until we cover every topic on the board. Look at them. Kinetic theory of matter, gas laws, Boyle's law, Charles' law, Dalton's law of partial pressure, general gas law, the ideal gas equation. We are not leaving here till we cover all these topics. We are not leaving here till we cover all these topics. We are not going anywhere. No leave, no transfer. No leave, no transfer. No leave, no transfer. So settle down and let us get started. Settle down. Get your writing materials. Make sure your phone is on DND. Do not disturb. Do not disturb. Make sure your phone is on Do Not Disturb. DND. Put your phone on DND. Me, I've removed my SIM card, so nobody can call me today. I have removed my SIM card. So even if you try calling me, it will not go. My students must pass their JAMB. I have removed my SIM card from my phone. Because most times when I'm teaching, students will be calling me from left, right, and center. And that will be interrupting our classes, interrupting our network. So I removed my SIM card. I've removed my SIM card today. Nobody can call me. Yes. So let us get the class started. No time to waste. Today, we want to look at the following topics. Day 3. Welcome to chemistry. Day 3. Welcome to the Jamb Master Life Chemistry. Day 3. We are on a 30-day challenge. In case you are new here, we are on a 30-day challenge. And in this 30-day challenge, we are covering your 4 subjects in JAMB, the complete JAMB syllabus for your 4 subjects. So every week we take one subject. Every week we take one subject. So this week we are on chemistry week so far. This week is chemistry week, and we have done day 1, we have done day 2. You can see this day 3. If you're just joining us and you missed day 1 and day 2, don't worry, there's a video. Just message me. As long as you're registered with us, you will get the 1 and day 2, and you can catch up. So this is day 3. So for the whole of this week, we are only doing chemistry. We are going to be teaching and coaching chemistry, and we have a topic target for every day. These are our target for today. Tomorrow we have our target for tomorrow. Till Sunday we are teaching only chemistry. Then next week we go into physics. So throughout next week is only physics we are going to be teaching throughout next week. We will not leave physics until we finish it. After physics we enter biology. After biology we enter mathematics. After mathematics we enter English. Yes. So every subject will be covered. Are we together? So this week is chemistry week. Let us get the ball rolling. Let us get started. Let us get started. Without wasting more time, class, the kinetic theory of matter. We all know that there are 3 states of matter. We all know that there are 3 states of matter. Please forgive me one more time before I start. If you can hear me clearly, let me know in the comment section. If you can hear me clearly, let me know in the comment section. It's very important that you can hear me. If you can see the board clearly, also let me know. Type, I can hear you clearly, sir. And I can see the board clearly. I can hear you clearly, sir. And I can see the board clearly. I can hear you clearly, sir. And I can see the board clearly. I can hear you clearly, sir. And I can see the board clearly. I can hear you clearly, sir. And I can see the board clearly. Let me know in the comment and I'll start. Give me the go ahead. Give me the go ahead to start. Give me the go ahead to start. You are the boss. You people are the boss here. Sir, we can hear you clearly. Sapphire on. Sapphire on, we can hear you. Don't worry, sir. Sir, the board is very clear. Let's go. Give me the go ahead. Good. Everybody's saying I can hear you, I can see. Good. I can hear you and I can see. Okay, I can go ahead then. Thank you for the permission. Now let's go. We're going to start with the states of matter. We have 3 states of matter. We have solid states, we have liquid, and we have gas. Class, matter can exist in 3 states: solid, liquid, and gas. It's either sometimes a solid, or is a liquid, or is a gas. Class, in the kinetic theory of matter, the scope of this particular topic is to help the students to understand the 3 different states of matter. Is to help the students to understand the 3 different states of matter. So class, I'll be listing the properties of a solid. How does a solid behave? How does a liquid behave? And how does a gas behave? Class, we're going to be talking about solids, liquid, but when we get to gases, we then push further. Class, the gases could not, you can't just list how gases behave. There were several laws that were postulated about gases, and that's what led us to the gas laws. So we're going to first start this topic with solid and liquid, then the main focus will be on gases. Because among these 3 states of matter, gases are the most interesting. Among the 3 states of matter, the gases are the most interesting because they are unpredictable. Are we together? They occupy a container where they are filled. They are highly compressible. You know, they can expand infinitely. So gases needed to be studied like in total. So class, in the kinetic theory of matter, we're supposed to talk about the 3 states of matter, then focus on the gases. When we say focus on the gases, we talk about the gas laws. All the gas laws. All these laws here, they have calculation and formula. So get ready for serious work today. Get ready for serious work. Now let's get started. We have a lot of things to do today. Class, let's start with the solids. How do the solids behave? Class, one thing you should know about solids is that they have a definite volume. Let's first start with definite shape. The solids have a definite shape. The liquid takes the shape of the container in which it's placed. The gases fill up the container in which they are placed. Just fill up. They fill up. They don't have any shape. They just fill up. That's the first thing you should know about the solid, liquid, and gas. Class, solids also have a definite volume. Liquids have a definite volume too. But class, again, we are going to repeat that the gases fill up the container in which they are placed. Of course, they have a definite volume, but they tend to just fill up the container in which they are placed. Now, class, coming to the 3rd point, we're going to talk about the intermolecular force of attraction between the molecules of a solid. Strong force of attraction between their molecules. Strong force of attraction between molecules of solid. The molecules of solid have a strong force of attraction. So there is very little movement between the molecules of a solid. So we can say that the molecules of a solid vibrate about their main positions. The molecules of a solid vibrate about their main positions. The molecules of a solid vibrate about their main positions. They have strong force of attraction between their molecules. Yes, the molecules of a solid are well tightly connected together. They have a strong force of attraction. Class, the liquid have a weaker force of attraction. Class, there is more freedom between what? The molecules of a liquid. That is, more freedom of movement between the molecules. More freedom of movements between molecules. Class, the gases have the weakest force of attraction, in case you ask in the exam. The weakest force of attraction between their molecules is the gases. Another thing you know about the liquid flow when poured. They flow. When poured, liquid do what? They flow when poured. Class, amongst these three, if you ask in the exam, which of the following state of matter has the highest kinetic energy? The highest average kinetic energy of the molecules. Class, what will be your answer? Between solid, liquid, and gas, which of the following states of matter has the highest what? Average kinetic energy. Class, what is kinetic energy? Kinetic energy is the energy of a body in motion. The energy that allows the body to move fast is kinetic energy. Class, you agree with me that the answer should be gases. The gases have the highest kinetic energy. Their molecules can move faster. Why? Because the force of attraction is weak. Because they have the force that holds their molecule together is not very strong. They can move faster. They can move what? So the highest average kinetic energy between the three states of matter is what? Is the gases. High kinetic energy. So if you ask to arrange solid, liquid, and gas in an increasing order of average kinetic energy in the exam, which of the following is the correct order? You know there are some wicked theoretical questions in chemistry that doesn't have to do with calculation. If you don't know it, you don't know it. No formula can save you. You just have to understand chemistry theoretically in your brain. There are two parts of chemistry. There's calculation in chemistry and there's the theoretical understanding of chemistry. Those theory questions they ask you that if you don't know, you don't know it. Particulate nature of matter. You know, surface tension, talking about Brownian motion, capillary action. Yes, those particulate nature of matter. Understanding chemistry total, not just calculation, not just knowing formula, not just knowing concentration is number of mole over volume, not just knowing that number of mole is mass over molar mass. Those are formula. Some people are good in formula aspect of subjects, but they are not good in understanding the concepts of the subject. Because you could be asked, arrange the following in increasing order of average kinetic energy, which will have this, what the highest kinetic energy is gases. The gases will have the highest kinetic energy. So it means that the gases have no definite shape or volume. They have no definite shape, no definite volume. Class, we've just broken down solid, liquid, and gas for you. It's now time to now focus on gas, as we said we'll do. We said we are going to now shift our focus purely to gas. Before I go to gas, because gas is the main focus of today's class, let me see if you are still with me and if you can still hear me. It's always good when you're doing an online class that you check up once to know what's going on. Please, if you can still hear me, type I can hear you, sir. If you can still hear me, type I can hear you, sir. If you can still hear me, type I can hear you, sir. If you can still hear me, type I can hear you, sir. Okay, someone say I did, sir, I'm with you. Yes. If you can hear me, please, it's important you give me updates. Let me know what I'm doing. If you can still hear me, you can see the board. Type I can hear you, sir. Please, it's important you update me. You know, in a live class, network could have gone and I would just be teaching. I won't know that you're not hearing me again. So please forgive me for always stopping to ask. It's good I ask. So I won't just be teaching and I don't know that you're not hearing me. If you can still hear me, type I can hear you, sir. Good. Nancy said I can hear you, sir. Precious Chidera said I can hear you, sir. Okay. One more person and I'll go and continue. One more person and I'll go and continue. One more person and I'll go and continue. Type I can hear you if you can still hear me. Okay, good. Now, let us go to our gas laws. Class, what I'm going to do today is I'm going to be teaching all the gas laws, then I'll start taking questions. So we'll give you all the gas laws, then we'll take questions. So let's finish all the laws, then we'll then come to questions. So this class has two aspects. The aspect where I state all the laws for you and explain what they mean, and the aspect where we'll now take calculation question under each law. Does that make sense? Let us state all the law and explain what the law means first. Then the second aspect will now be let us start taking calculation questions. Let us go. 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 So class, let us start with Boyle's law. Class, basically what the gas laws help us to understand is the different parameters involving gases, especially something like pressure of gas, The gas laws help us to understand the relationship between pressure of gases, volume of gases, temperature of gases. Some gas laws even go as far as number of moles of gases, mass of gas. Everything that has to do with gas. How do these quantities relate to each other? So each law is always telling you about the relationship between one quantity to another. So the first thing you should know is that Boyle's law focuses on the relationship between pressure of gas and volume of gas. If temperature is constant, if temperature is kept constant, if temperature is kept what? Constant. When temperature is kept constant, what happens to the relationship between the pressure of a gas and the volume of a gas? That's what Boyle's law helps us to understand. So let us go to stating Boyle's law. The Boyle's law states that the pressure of a given mass of a gas, the pressure of a given mass of a gas is inversely proportional. The pressure of a given mass of a gas is inversely proportional to the volume. At constant temperature. That is, when temperature is constant, pressure and volume are inversely proportional. Now, what does it mean for pressure to be inversely proportional to volume? It means that pressure P is inversely proportional, that is proportional to 1 over V. Pressure P is inversely proportional to 1 over V. And this will imply, class, anytime you have a proportionality sign, a constant will come in to change this to equal to. This will now be pressure will now be equal to K all over V. So that if we cross multiply, we can have that K means a constant, K is a constant. K will be equal to P times V. K will be equal to P times V. And class, the key formula that we can derive from Boyle's law is that for every product of the pressure and volume in one phase will be equal to the same product of pressure and volume in another phase. What does it mean? It simply means that P1 V1, that is initial pressure times initial volume, will always be equal to final pressure times final volume. Class, this is the take home from this. This is the take home from this. Class, please note that this is not your secondary school, so this is an exam cracker class. So we are just trying to push you towards exam. So this is an exam focus. Are we together? If you're there and you really want to understand chemistry, after you have smashed your Jamb, before posterior midterm, you just want to understand chemistry well, we have a class where we'll teach you from the foundation, just teach you like we can repeat secondary school for you again. If you're on my channel, you're in a school, this is a school. So your secondary school is not teaching chemistry very well, I will now come in. There are a lot of things I'm not mentioning because we just want to focus on exam. Remember that there's only 40 questions in Jamb. So there are a lot of things your examiner is not setting, is not talking about. Because you can only set 40 questions. So we are going to the key formulas that the examiner can set. Are we together? So, but in your secondary school now, they normally teach you from chapter 1, everything slowly. If you want a very slow pace, little by little class, like a normal school, first 10, second 10, top 10, after your Jamb, there's a little space before posterior ME. Yes, we used to hold another crash course where we are going to take each course on the foundation. So teach me chemistry very well. Before university exposes me. Before I enter school, I want to know chemistry and physics very well. So teach me chemistry from the beginning. My school did not try at all. So teach me mathematics from the beginning. Class, this is not the time for that one. That one is after your Jamb, because Jamb is just next month, 16th of April. This one is, sir, just to give us what we need to pass. Let us go and pass first. After you have passed, sir, I have students that meet me, parents meet my resources. Can you train my daughter? We are not sure if that's going to she went to. Before she enter university and go and fall her hand, please teach her chemistry, physics, math very well from the beginning. Let her know it before she enters school. Yes, we do that one, but class, this is not the time for that. This one is time for you to just pass your exam. Pass your exam. You see, that's why I'm very fast. So please take note. This is not where you come and learn foundations of chemistry. No. This one is just go and pass your exam and move forward. Let's go to the next law. Let's go to the next law. There's no time to waste. Charles' law. Let's go to Charles' law. So I've just closed up Boyle's law. Charles' law. States that, class, Charles' law gives relationship between volume of gas and temperature of gas if pressure is kept constant. This time around, pressure is kept constant. In Charles' law, the pressure is kept constant. Charles' law gives relationship between volume of gas and temperature of gas. According to Charles' law tells us that the volume of a gas is directly proportional to the temperature of the gas. Volume of gas is directly proportional to temperature. So class, why Boyle's law says that pressure of gas and volume are inverse, right? Boyle's law tells us that pressure is inverse proportional to volume. Charles' law is telling us that the volume of a gas is directly proportional to the temperature. So according to Charles' law, it states that the volume of a given mass of a gas, Charles' law states that the volume of a given mass of a gas is directly proportional to the absolute temperature. Absolute temperature in Kelvin. In what? Provided the pressure is kept constant. Provided the pressure is kept constant. Yeah, the volume of a given mass of a gas is direct to temperature if pressure is constant. So we're going to have V1 all over T1 equals to V2 all over T2. Please, never solve temperature if it's not in Kelvin. If it's in degrees Celsius, always convert to Kelvin. Remember how to convert from degrees Celsius to Kelvin? If you have 23 degrees Celsius and you want to go to Kelvin, what do? Add 273. From degrees Celsius to Kelvin, add 273. Because most likely they will want to test you in the exam and give you your temperature in degrees Celsius. It's your job as a good chemistry student to convert from degrees Celsius to Kelvin. How do you go from degrees Celsius to Kelvin? Add 273. Always add 273. From degrees Celsius to Kelvin, always add 273. Let me see if you are still with me. Let me see if you can still hear me. If you can still hear me, give me your update. Give me your update. Update me, please. Update me, please. Sir, can you still hear me? Can you still see the board? Can you still hear me? Please give me the new update. What's the latest update? Can you still hear me? Can you still see the board? Can you still hear me? Can you still see the board? Can you still hear me? Can you still see the board? Can you still hear me? Can you still see the board? Drop a comment. Drop a comment. Let me be sure that you can still hear me. Drop a comment. Drop a comment. Sir, I can hear you. Someone should drop a comment. Go. Thank you, Rosemary. Rosemary say yes, sir. Who else can hear the board? Who else can see the board? Who else can hear me well? Good, 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 good. This is Charles' law. This is Charles' law. Make sure you are writing. Make sure you are writing. Make sure you are writing. The next law we're going to look at is the general. Before we go to the general gas law, let us look at Gay-Lussac's pressure law. We're going to look at Gay-Lussac's pressure law. Gay-Lussac's pressure law. Before we go to the next law, we'll look at Gay-Lussac's pressure law. So from degrees Celsius to Kelvin, always add 273. From degrees Celsius to Kelvin, always add 273. Never solve your gas laws with degrees Celsius. Always convert to Kelvin. Never solve your gas laws in degrees Celsius. Always convert to Kelvin. And from degrees Celsius to Kelvin, you add 273. From degrees Celsius to Kelvin, you add 273. Yes, let's go, let's go, let's go. Let's go. Remember we said our commitment. I will not live to the end. Don't forget our commitments. Every day we make a commitment when we start our class. I will not live to the end. Type in the comment section. I will not live to the end. I will not live to the end. Type it in the comment section now. I will not live to the end. Type it in the comment section. I will not live till the end. I will not live to the end. Let's go to Gay-Lussac's pressure law. Class, if you notice, Boyle's law has given us relation between pressure and volume. Charles' law gave us relation between volume and temperature. Gay-Lussac's law gives us relation between pressure and temperature. if volume is kept constant. According to Gay-Lussac's pressure law, it states that. So class, Gay-Lussac has two laws in the gas laws. He has the pressure law, and he has this one too, Gay-Lussac's law of combining volume. We are coming to that. Gay-Lussac's law of combining volume. So Gay-Lussac has two laws in the gas laws. Please take notes. Gay-Lussac has two laws in the gas law. The Gay-Lussac's pressure law and Gay-Lussac's law of combining volume. But let's take Gay-Lussac's pressure law first. It states that the pressure of a given mass of gas is directly proportional to the temperature provided volume is kept constant. Provided volume is kept constant. So according to Gay-Lussac's pressure law, pressure P is directly proportional to temperature T. And what this means is that pressure P will now be equal to KT. Making K square the formula, we are going to have P all over T. And the key formula in Gay-Lussac's pressure law is P1 over T1 equals to P2 all over T2. This is the key formula from Gay-Lussac's pressure law. P1 represents initial pressure, T1 represents initial temperature, P2 represents final pressure, T2 represents final temperature. Class, they'll give you a question like this: given that the pressure of a gas is so and so, and the temperature is so and so, what will be the new pressure if the temperature is now increased to this? What happens to pressure when temperature is increased to this? Let me give you a key shortcut in gas law that you should note. Class, when two quantities are directly proportional, anytime there's an increase in one, there will be an increase in the other. So class, if someone had a pressure, initial pressure of maybe 2 atm, and initial temperature of maybe 5 Kelvin. Now if the pressure for any reason is increased to 4 atm, atm means it's one of the units for pressure, you know that? Class, and they say to find the final temperature, T2. Class, don't expect the temperature to be lower than 5. It will be higher. Why? Because the pressure increase, the temperature must also increase. Why? Because pressure and temperature are direct proportion. So in your options, even if you don't know what to do, and you have option A, B, C, D, any option that is less than 5 is out of it. Eliminate it. That's elimination. Elimination, smart elimination method. Eliminate any option that is less than 5, cannot be your answer. Why? Class, anytime two quantities are directly proportional to each other, an increase in one will lead to a proportionate increase in the other. An increase in one will lead to a proportionate increase in the other. Class, even without solving, I can tell you, if P1 is 2 atm and P2 is 4 atm, class, the difference between 2 and 4 is that 2 times 2 is what? 4. Class, I can tell you that my temperature is also 5 times 2 is 10 Kelvin. If this guy was multiplied by 2, this guy also multiplied by 2. That's the idea, class. If this guy is divided by 2, this guy also divided by 2. Whatever happens to this guy happens to this guy. That's the idea, class. And even the pressure was reduced, the temperature will also be reduced. But because the pressure was increased, temperature will also be increased. And the pressure was increased by 2. 2 times 2 is 4. So old pressure is 2, new pressure is 4. So it means that pressure was increased by 2. 2 times 2, 4. I can be, without even solving, I can say that my temperature will also be increased by 2. 5 times 2, 10. It's a key concept. You understand this, you will not struggle in gas laws. If you understand this. But this works for direct proportion. Direct what? Proportion. But let's go back to Boyle's law where that was inversely proportional. Boyle's law says that pressure is inversely proportional to volume, right? Class, for this one, anything that happens here, the reverse happens here. So if you increase this guy by 2, this guy will reduce by 2. Because this is inversely proportional to this. So if this was the question, P1 equals to 2 atm and V1 equals to 5 liters. If P2 is now 4 atm, class. So P2 was increased, the new pressure is when the old pressure multiplied by 2. 2 times 2 is 4, right? What will happen to the new volume? Class, this guy will not follow and multiply by 2 because why? They are not directly proportional, they are inversely proportional. This guy will actually instead divide by 2. So our new volume will be 5 divided by 2, which is 2.5 liter. So class, what it means is that when two quantities are inversely proportional to each other, whatever happens to one, the opposite happens to the other. If this guy is multiplied by 2, this guy will be divided by 2. But if this guy is divided by 2, this guy will be multiplied by 2. When two quantities are inversely proportional to each other, whatever happens to one, the opposite happens to the other. But when two quantities are directly proportional to each other, whatever happens to one, the same happens to the other. Please take note. Please take note. Let us keep going. So this is pressure law. Gilusa's pressure law, we have done it now. Charles law, we have done it. Boyle's law, we have done it. Let us now look at the general gas laws. General gas laws. Class, the general gas law. It's not actually a law per se, class. It's just an equation that brings together the three laws we have done so far, which is Charles' law, Boyle's law, and what? Gilusa's pressure law. Class, and the formula is that the P1 V1 all over T1 equals to P2 V2 all over T2. P1 V1 all over T1 equals to P2 V2 all over T2. So in the general gas law, it brings pressure, volume, and temperature together. The general gas law brings pressure, volume, and temperature together. General gas law brings pressure, volume, and temperature together. General gas law brings pressure, volume, and temperature together. Let us keep going. So that's general gas law for you, straightforward. What you just need to know is that sometimes they can tell you at STP. Class, at STP means that they are giving you temperature and pressure already. Class, at STP, please take note that temperature is 273 Kelvin and pressure is 1 atm or 760 millimeter mercury. Class, at standard temperature and pressure, STP means standard temperature and pressure. STP means standard temperature and pressure. The pressure is 1 atm or 760 millimeter mercury. Class, also note that if they tell you that a gas is collected over water, when a gas is collected over water, when gas is collected over water, when a gas is collected over water, you usually be given the vapor pressure of the gas. They will give you the vapor pressure of the water. Sorry, the vapor pressure of the water. Class, your job is to remove that pressure of the water from the total pressure they give before you solve. They can tell you the pressure of water is 20 millimeter mercury. And they give you total pressure of the gas is 750 millimeter mercury. Class, before you start solving, you will say 750 minus 20. Your real pressure is 730. Because the gas was collected over water. Don't worry, when we get calculation aspect, I'll give you a question. I'm just telling you now, so remember I said it. Are we together? Yes. So please take note. When they tell you the gas collected over water, be careful not to use the pressure of the gas just like that. Until you subtract that pressure of water from the total pressure of the there, you now get the real pressure of the gas. If you use this pressure at 750 without subtracting this 20 first, class, your answer will be wrong. Your answer will be wrong. Let us keep going. Let us keep going. I like the energy we have been going with so far. We have been covering. You can see the idea. Some of you, I think you are this day 3 now. So somehow you should have started saying the light. Oh, this makes sense. Okay, so this is the idea. And those people didn't really understand the idea before now. They really understand. But you are saying it day by day. Okay, it's turning up every day. It's working on her. I will not miss one day. I don't miss my classes. Every day we will learn. Some days I will start early than the day. So that I'm ready. I'm serious. Ideal gas equation is the next thing. Ideal gas equation. Ideal gas equation. Class, ideal gas equation is not also a law. We are not stating any law here. It's just something you should know that the ideal gas equation tells us that PV, the ideal gas equation relates the pressure and volume of the gas to the number of moles, the gas constant R, and temperature T. This is the ideal gas equation. PV equals to nRT. Class, why do we call it ideal gas equation? Because class, there are 2 types of gases. In chemistry, there are 2 types of gases. We have the real gas and the ideal gas. Class, let me shock you. Are you aware that these gas laws, the real gas in real life, they don't obey the gas laws that we are learning in chemistry in school every day? The real gas in real life, when you go and fill your gas that you used to cook in the house, those gases don't obey the gas law because they are not ideal gas. They contain some level of impurity. They are not perfect gases. Who are ideal gases? Ideal gases are perfect gases that don't contain any impurity. That means all things being equal, nothing is wrong with this gas. It will obey the gas law. But class, the real gas does not obey the gas law. Class, so there's what we call the ideal gas equation. And there's what we call the real gas equation stated by Van der Waals. But I will not go that far. That's for my 100 level, 200 level chemistry students. Nobody in Jamb will ask you for the Van der Waals real equation, real gas equation. It's called Van der Waals real gas equation. I just taught it to my 100 level students not too long ago. Are we together? But it's not in your Jamb scope, so let's not waste time. But I'm just telling you so that when you get to 100 level, because at the end of this year you'll be in 100 level. By the end of this year you'll be in 100 level in the course you are applying for. And your lecturer will be teaching you what? Real gas equation in chemistry and ideal gas equation. So Jamb asks us to only do ideal gas equation. But it's important for me to let you know that there are two types of gases in chemistry. Real gases are gases that do not obey the gas laws. Ideal gases are gases that obey the gas laws. They are perfect gases. So this is the ideal gas equation. Ideal gas equation. PV equals to nRT. Where P is pressure, we know that. V is volume. N is number of moles. R is gas constant, and it's a constant 0.0821 atm liter per mole per Kelvin. Of course, temperature T is in Kelvin. Your temperature T is in Kelvin. N is number of moles. R is gas constant 0.0821 atm liter per mole per Kelvin. Class, but they can shock you with this ideal gas equation, and you will not use 0.081. Instead, you will use 8.314. I will tell you when do you use 8.314 and when do you use 0.081. 8.314 joules per mole per Kelvin. Class, when you use 0.081, when your pressure is in atm, they give you your pressure in atm. They give you your volume in liters. Your temperature must obviously be in Kelvin. You are going to use 0.0821. But class, when your pressure is not given in atm, if it is given in Pascal, because pressure has different units. It has Pascal, it has Newton per meter square. Class, anytime you see your pressure given in Pascal or Newton per meter square, immediately know that this is not the gas, the gas constant you use this gas constant. R stands for gas, ideal gas constant. This symbol R stands for ideal gas constant. So you use 0.0821 when your pressure is given in atm, volume in liters, temperature in Kelvin. You use 8.314 when your pressure is given in Pascal and your volume is given in meter cube. Your volume is given in meter cube, but your temperature and your temperature is still Kelvin. Temperature is still what? Kelvin. These are the two guys that you used to know if you should use this or this. When pressure is in atm, use this, and volume is in liter, use this. See, atm liter. But when pressure is in Pascal or Newton per meter square, use this. Now, how do we convert from atm to Pascal? Class, 1 atm is equivalent to 101,325 Pascal or Newton per meter square. Class, Pascal and Newton per meter square, they mean the same thing. Pascal and Newton per meter square, they mean the same thing. But class, there are sometimes that you are supposed to use this guy, but they will not give you a pressure in atm and they will not give you a pressure in Pascal, but you are supposed to use this guy. They will give you a pressure in millimeter mercury. You need to now convert from millimeter mercury to atm. 1 atm is equivalent to 760 millimeter mercury. 1 atm is equivalent to 760 millimeter mercury. So class, they gave you a question on ideal gas and they gave you 500 millimeter mercury. Class, there is no space for millimeter mercury in ideal gas equation. You need to convert millimeter mercury to atm so that you can use this first gas constant. How do you convert from millimeter mercury to atm? Divide by what? 760. From millimeter mercury to atm, divide by 760. Because 1 atm is equivalent to 760 millimeter mercury. Divide by 760. And get your answer. I'm just preparing you for our potential calculation. We'll go to calculation. Don't forget the agreement. Let's state all the laws, explain them, then start taking questions and end for the day. Are we together? So class, take note of that. If they give you a pressure in millimeter mercury, never use it to solve in the ideal gas equation. Convert it to atm. Are we together? They give you a volume in ml. Like say 300 ml. Class, your volume should be in liter. Divide it by what? I taught you this yesterday. Divide by 1000 to go to what? Liter. 3000 ml to liter. Convert to liter. Never use it in mil. This milliliter. ml means milliliter. ml means milliliter. ml means milliliter. Never use your volume in milliliter in ID gas. Convert to liter. Because the equations are simple. The problem is the units they will give you. If you don't convert to the right unit and you use that unit like that, you might see your answer in the option and think you are right, but you are wrong. The people that said Jamb exam are professional, so they already put your mistakes in the options. So be very careful. Never use mil, convert to liter, divide by 1000. Class, but they give you your volume in dm cube instead of liter. They give you like 3.2 dm cube. Yes, you don't need to convert. Do you know why? Because I told you yesterday that dm cube and liter means the same thing. 3.2 dm cube means 3.2 liter. 3.2 dm cube. 3.2 dm cube means 3.2 liter. Liter and dm cube have the same value in chemistry. So you don't need to convert. You don't need to convert. Please take note. But they give you your volume in ml or cm cube. You must convert. If they give you 300 centimeter cube, you must convert. Divide by 1000. Divide by. If they give you 300 ml, divide by 1000 to change it to liter. Please take note. Please take note. Class, one more thing about ideal gas equation you should learn. One more thing about ideal gas equation you should learn. Class, it could ask you to find the density of an ideal gas. And if you look at this equation, there is no space for density. So we're going to derive another equation from here. Class, we're going to take advantage of this n number of moles. I want you to recall the number of mole is mass all over molar mass. Recall that we have done number of mole in this day 1, and it's mass divided by molar mass. Meaning anywhere I see n, I can put mass over molar mass. So this ideal gas equation can change to PV equals to, instead of n, you have what? Mass all over molar mass RT. Because class, you can cry one formula and they give you a question that requires you to use another formula, a derivative of this formula. I want to derive another formula from this formula. Let us cross multiply. We're going to have PVM equals to small m RT. If you are in my class in day 1, you know the difference between small m and big M. If you are in my class in day 1, by now you know the difference between small m and big M. Let me check for updates. I hope you can still hear me. Yes, everybody's following. Everybody's following. Someone said I will not live to the end. That's the energy. Someone said I will not live to the end. I like this said. If you can still hear me, you can see the board. Say yes, sir. Yes, sir, I can hear you. If you can still hear me, you can see the board. Say yes, sir, I can hear you. Class, in day 1, I taught you between big M. Big M means relative molecular mass, right? Or molar mass. Small m means given mass. So we'll cross multiply so that PV big M equals to small m RT. Let's divide both sides by V. V cancels V. So that PM, that's pressure times molecular mass, equals to what? Small mass all over V RT. Please note this formula, very important. This is very important on its own. But class, I want to remind you that density is mass all over volume. Do you remember? Density of a gas is the mass of the gas divided by the volume. Meaning that I can replace this mass over volume with density. So that PM equals to density. I replace mass over volume with what? Density. Why? Because density is mass all over volume. So density RT. Now make density straight to the formula. Density will now be equal to PM all over RT. Class, this is the formula for density of an ideal gas. The density of an ideal gas is the pressure of the gas times the molecular mass of the gas divided by the gas constant R times temperature T. Density of an ideal gas. Density of an ideal gas. Let us go, guys. Let us go. Let us go. We are making progress. We are making progress. We are making progress. Let's keep going. 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 Let us keep going. Let us keep going. Let us keep going. Please permit me to clean the board. Remember, you can rewind and watch again. One thing I like about the class so far is that nobody's complaining again. I don't understand, sir. Nobody's saying, sir, you are too fast. Because now you know that in an online class, if you don't understand, the power is in your hand. You don't need to type it. The time you need to type, just rewind the video and watch again. The time you need to type, sir, you are too fast. Slow down the speed of your video. You can slow it down. Go and learn about YouTube. You can slow down the speed of the teacher in your phone. and you'll be learning at a slower pace. So nobody's typing, sir, I don't understand, sir, you are too fast. Everybody's now understanding, right? Everybody now knows what to do. If you are lost, just rewind and watch again. Good. You are now becoming my student now. This is how my students behave. Yes. Yes. So everybody now knows what to do. That first day when you first started, sir, I don't understand, sir, you are too fast. We have forgotten that you are in an online class. You can rewind and watch again. Let us go to Dalton's law of partial pressure. Dalton's law of partial pressure. Dalton's law of partial pressure states that if there is a mixture of gases which do not react chemically together, if there is a mixture of gases, if there is a mixture of gases which do not react chemically together, if there is a mixture of gases which do not react chemically together, then the total pressure exerted by the mixture is a sum of the partial pressure of the individual gases that make up the mixture. States that what if there is a mixture of gases which do not react chemically together, then the total pressure exerted by the mixture is a sum of the partial pressure of the individual gases that make up the mixture. What does this mean, class? What this means is that if there is a mixture of gases, let us say gas A, gas B, and gas C. Let the pressure of A be PA, let the pressure of B be PB, let the pressure of C be PC. So a mixture contains three gases, A, B, and C. Class, the pressure of each component of the mixture is called partial pressure. When a mixture contains more than one component, the pressure of each of the components is called partial pressure. So this is partial pressure of A, partial pressure of B, and partial pressure of C. According to Dalton's law of partial pressure, Dalton's law is telling us total pressure exerted in the whole mixture containing A, B, and C is a sum of the partial pressure of the individual gases that makes up the mixture. That means the total pressure of the mixture is pressure of A plus pressure of B plus pressure of C. Class, mathematically this is what Dalton's law of partial pressure is telling us about. The total pressure exerted by a mixture is a sum of the partial pressure of the individual gases that make up the mixture. Class, a second version of this Dalton's law of partial pressure can consider the number of moles of the first gas, number of moles of the second gas, and number of moles of the third gas. If a mixture contains three gases A, B, and C, if you don't want to use their pressure, you can use their number of moles. Number of moles of A, number of moles of B, and number of moles of C. Total number of moles of the mixture, class, will be number of moles of A plus number of moles of B plus number of moles of C. Class, we can now find the relationship between the pressure and the number of moles. And we know that the pressure of any given gas is directly proportional to the number of moles. Pressure of any given gas is directly proportional to the number of moles of the gas. What this means is that mathematically you can say that PA all over NA, that is pressure of gas A divided by number of moles of gas A, can be equal to pressure of gas B divided by number of moles of gas B, can be equal to pressure of gas C divided by number of moles of gas C, and can be equal to total pressure of the gas divided by number of moles, total number of moles of the mixture. Pressure of gas A all over number of moles of gas A, pressure of gas B all over number of moles of gas B, pressure of gas C divided by number of moles of gas C, total pressure of the mixture, PT means total pressure. Total pressure of the mixture divided by total number of moles of the mixture. Please take note. This is Dalton's law of partial pressure. This is Dalton's law of partial pressure. Take 30 seconds and write. Take 30 seconds and write. Take 30 seconds and write before I clean. Take 30 seconds, write before I clean. If you can still hear me, give me the latest update. What's the update? What's the update? Can you still hear me? What's the latest? What's the latest? Can you still hear me? If you can hear me, say I can hear you, sir. Can you still hear me? Good, good, good. Precious Chidera, thank you. You're always updating me. Thank you. Thank you. I'm giving you a few minutes to write if I continue. Let me slow down the pace a bit. If you are done writing, say I am done writing, sir. If you are done writing, say I am done writing, sir. Please, if you are lost, rewind the video and watch again. Precious Chidera, I've already said this before. Rewind the video and watch again. Rewind the video and watch again. I've said this before. Let's go to the next law. Gay-Lussac law combining volume. Oh, sorry, Graham's law of diffusion. Graham's law of diffusion. Graham's law of diffusion. According to Dalton's law of partial pressure, what it's telling us is that when a mixture contains three components, A, B, and C. When a mixture contains three components, A, B, and C. The first component of the mixture is A. The pressure of A is PA. Pressure of B is PB. Pressure of C is PC. If a mixture contains three components, component A, component B, and component C. The pressure of A is PA, pressure of B is PB, pressure of C is PC. Now the total pressure of the mixture, that's the total pressure of the mixture as a whole, is equal to the sum of the pressure of each component of the mixture, that's PA plus PB plus PC. That's the formula for Dalton's law of partial pressure. And we said, okay, we don't want to use pressure, we can use number of moles. If a mixture contains A, B, and C, the NA means number of moles of A, NB means number of moles of B, and NC means number of moles of C. So A, B, and C are inside the mixture, right? The total number of moles of the mixture is the sum of the number of moles of A plus number of moles of B plus number of moles of C. That's what that is law of partial pressure is telling us. And I then came to say that the pressure of any gas is directly proportional to the number of moles. The pressure of any gas is directly proportional to the number of moles. This will imply that a constant will come in P now equals to Kn. And means that K equals to P all over N. K equals to P all over N, meaning that for every pressure divided by number of moles, it will give us a constant. So pressure of gas A divided by number of moles of gas A will be equal to pressure of gas B divided by number of moles of gas B, pressure of gas C divided by number of moles of gas C. Who is gas A, B, and C? They are the three gases that make up a mixture class. If a mixture contains three gases, look at, state that if there is a mixture of gases, if there is a mixture of, that is not partial pressure, states that if there is a mixture of gases which do not react chemically together, then the total pressure exerted by the mixture, the total pressure of the mixture is a sum. Sum means add up. Sum means what? Add up. Is a sum of the partial pressure of the individual gases. That is individual gases A, gas B, and gas C that make up the mixture. So total pressure is PA plus PB plus PC. And then we have these formulas. I've just explained again. Even if I supposed to have rewinded the video, but I've explained it again now. Let's go ahead, let's go ahead, let's go ahead. Some of these things will make more sense when we start taking questions. It will make more sense when we start taking questions. But we said we'll finish the laws first, then we'll take questions and end for the day. Finish the laws first, then we'll take questions. Graham's law of diffusion. The rate of diffusion states that. Graham's law of diffusion states that the rate of diffusion of a gas states that the rate of diffusion of a gas is inversely proportional to the square root of the vapor density of the gas. Is inversely proportional to the square root of the vapor of the gas, provided the temperature and pressure remains constant. Provided the temperature and pressure remains constant. Provided the temperature and pressure is what? Is constant. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the vapor density of the gas, provided the temperature and pressure remains constant. Class, what's the vapor density of the gas? I want you to know that the vapor density of a gas is equals to the relative molecular mass of the gas divided by 2. The vapor density of a gas is equal to the relative molecular mass or the relative atomic mass divided by 2. Class, don't forget yesterday I told you that we use relative molecular mass for molecules. We use relative atomic mass for atoms. Why am I using these two formulas? Because the gas can be in a molecule form, it can be in an atom form. For example, hydrogen is a gas. But ammonia Na3 is also a gas. And ammonia is a molecule, but hydrogen is an atom. Do you get? We use RAM, relative atomic mass, for atoms. And we use RMM, relative molecular mass, for molecules. But the vapor density of any gas is the relative molecular mass divided by 2 or the relative atomic mass divided by 2. Please take notes. So class, if someone gave you the relative molecular mass of a gas, they're giving you the vapor density. Why? Just divide it by 2. If the relative molecular mass of a gas is 64, then the vapor density of the gas is 64 divided by 2, giving you 32. If the relative molecular mass of the gas is 64, the vapor density is relative molecular mass divided by 2. Relative molecular mass divided by 2. Please take note. So now let's apply the Graham's law of diffusion. He said that the rate of diffusion of a gas, R, is inversely proportional to the square root of the vapor density, D. So R is inversely proportional to the square root of D, which is the vapor density. Class, what this means that when a constant comes in, we're going to have R equals to K all over root D. And what this then means is that R1 all over root D1 or we can just call it this way. If you want to look at it this way, you can say R1 root D1 equals to R2 root D2, where R1 represents initial rate of diffusion, D1 represents initial density, R2 represents final rate of diffusion, D2 represents final density, final vapor density. Are we together? This can still be written as R1 all over R2 equals to what? Root D2 all over root D1. Please note all these formulas. Question time is coming. Note all these formulas. Question time is coming. R1 over R2 equals to root D2 all over root D1. In the exam, you could be asked to find just separately, individually, what is the rate of diffusion of a gas? What is the formula for rate of diffusion of a gas on its own? The formula for rate of diffusion of a gas is the volume of the gas divided by the time taken for the gas to diffuse. Rate of diffusion is volume of gas divided by time taken for gas to diffuse. Rate of diffusion is volume of gas divided by time taken for gas to diffuse. Class, we can still relate this same formula to relative molecular mass. R1 all over R2 equals to root M2 all over root M1. What does M mean? M means relative molecular mass if the gas is a molecule, or relative atomic mass if the gas is an atom. M means relative molecular mass if the gas is a molecule, or relative atomic mass if the gas is an atom. Because class, sometimes they will not give you rate of diffusion and density, they will give you rate of diffusion and relative molecular mass. And that's to find, they will leave one unknown, say find that one. Are we together? This can still be related to T2, that is final time of diffusion, all over initial time of diffusion. This can also come in, this can also come in. Don't forget, when we take questions, it will make more sense. When we take questions, it will make more sense. When we take questions, it will make more sense. When we take questions, it will make more sense. If you can still hear me, say, sir, I am with you. We have just crossed 60 minutes, 1 hour of class, back to back. This is good. If you can still hear me, say, sir, I am with you. If you can still hear me, say, sir, I am with you. We have 2 more laws, then we'll start taking questions. 2 more laws, then we'll start taking questions. Make sure you are reading 2 hours every day. Make sure you are studying. Ensure, make sure you are reading. Make sure you are reading. It's now time to also start doing Jamb pass questions. Every day, make sure that at least 1 year of Jamb pass question goes down from your end. Take a year of Jamb pass question from number 1 to 40. Take a subject. Have a subject you are doing every day. Say, okay, I will answer every question in this question and correct myself. You understand? As you're coming for class 2, make sure you're doing your personal study. It goes hand in hand. Make sure you're doing your personal study. Make sure you are driven to score high. Before you can score high, you have to want it for yourself. You have to be driven to score high. You have to be driven to score high. I'm not going to be driven for you. You have to be driven to score high. You have to work it out. One of our students messaged me, sir, I've been reading this week. Sent me a question. I said, this is good. Means you are reading. Sir, can you help me? I said, this is the energy. Well done. So make sure you're also putting in your personal effort. Study, push yourself, help yourself. Let us help you and let us help each other. Heaven help those who help themselves. Heaven help those who help themselves. Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume states that when gases react, they do so in volumes. When gases react, they do so in volumes which are in simple ratio to each other. And to the volume of their product. Provided the temperature and pressure remains constant. Gay-Lussac's law of combining volumes states that when gases react, they do so in volumes which are in simple ratio to each other and to the volume of their product, provided temperature and pressure remains constant. Class, the Euler's law is trying to tell us that when gases react, they do so in their what simple volume. If hydrogen reacts with oxygen to give H2O, we have 2 here and we have 2 here. What is trying to tell us that they do so in simple what? Volumes. They do so in volumes, which are in simple ratio to each other. So class, this is 2 ratio 1 ratio 2. When we get to question time, I'll tell you what we call volume of residual gas. Yeah, they can also find the volume of residual gas when 2 gases react. Total volume of gas used up, total volume of gas remaining. We are going to do that when we get to question time. But the Euler's law does not have one particular formula. It's an understanding that when gases react, they react in simple ratio to each other and even to the volume of their product. So 2 to 1 to 2. So 2 moles of hydrogen reacted with 1 mole of oxygen to give 2 moles of H2O. You can definitely interpret it as 2 volumes of hydrogen react with 1 volume of oxygen to give 2 volumes of H2O gas. Don't forget that water can exist as gas, steam. When you are boiling your water for garri, when the water gets to 100 degrees Celsius, it starts turning to gas, steam. Water in gaseous form is called what? Steam. Let's look at the last law and then we'll start taking questions. Let's look at the last law, Avogadro's law. Avogadro's law. Avogadro is an Italian chemist. Avogadro is an Italian chemist. Avogadro's law. Avogadro's law states that Avogadro's law. Class, we have cleared our chart for today. Congratulations. Look at it. We are doing it. I intentionally put Saturday and Sunday organic chemistry because at least most people will be at home by then. Organic chemistry is where the work is. Organic chemistry, Saturday and Sunday. Get ready. Get ready. So you say I gave 2 days for organic chemistry, 2 days. Avogadro's law states that Avogadro's law states that equal volume of all gases at the same temperature and pressure contain the same number of molecules. Avogadro's law states that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. According to Avogadro's law, it relates volume to number of molecules. But the volume of a gas is related to the number of what? Molecules. Class, they rarely ask questions on Avogadro's law because there's nothing really to ask. It's just an understanding that equal volume of all gases at the same temperature and pressure contain the same number of molecules. If you are ready for questions, say, sir, ready, we are ready. If we are still there, when I say you will not live to the end, you said you will not live to the end. We are ready for questions, sir, we are ready. Let us start questions. 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 Are we ready? Are we ready? Are we ready? Sir, we are ready. Let us start questions. We are ready. If you are ready, say we are ready. We are ready. If you are still with me, say, sir, let us start. Let us start. Let me see the comment and we'll start. Let me see the comment if you are ready for questions. Good, Rosemary. Thank you. Thank you. Yes, you're ready for question. Let us go. Let us go. Class. First things first. What do you think happens if you increase the temperature of a gas? Increase in temperature of a gas. Do you think it will increase the kinetic energy or reduce the kinetic energy? What does the increase in temperature of a gas? How does it affect the average kinetic energy of a gas? How does the increase in temperature of a gas affect the average kinetic energy of the gas? Do you think if we increase temperature, the gas will have a higher kinetic energy or a lower kinetic energy? Let me know. When you increase temperature of the gas, how does it affect the average kinetic energy? Please take note that when you increase the temperature of the gas, it increases the average kinetic energy of the gas. The gas molecules move faster with increase in temperature. Increase in temperature causes the gas molecules to move faster. Please take note. That's just a theoretical question. That's just a theoretical question. Let's take our first question for today. cm cube of a gas. 300 cm cube of a gas has a pressure of 800 millimeter mercury. 300 cm cube of a gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650 millimeter mercury, find its volume. Find its volume. They give us options. Option A, we have 243.75 cm cube. Option B, we have 369.23 cm cube. Option C, we have 738.46 cm cube. Option D, we have 1733.36 cm cube. Class, a very good chemistry student, as soon as you see a question, you should already know the law that the question is coming from. We are told that 300 cm cube of a gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650 millimeter mercury, find its volume. It is clear that this is between pressure and volume, and this is Boyle's law. You will not remember the formula I gave you in Boyle's law, that P1V1 equals to P2V2. Go back to your note, you see this formula, Boyle's law. Notice that there was no mention of temperature in this question, just between pressure and volume. Also notice that it's supposed to find the volume, and our final answer is in cm cube in the options. So no need to convert cm cube to dm cube, because your final answer should be cm cube. If you check the option and your answers were given in the dm cube, then you would have needed to convert your volume to dm cube. How do you convert from cm cube to dm cube? Divide by 1000. So class, we now know that this is the formula we are going to use, because this is between volume and pressure. And the law that gives us between volume and pressure is Boyle's law. It says P1V1 equals to P2V2. Let us now find out who is our P1, who is our V1. Our P1 as pressure is 800 millimeter mercury. Our V1 is 300 centimeter cube. If the pressure is reduced to 650, class, let me tell you something now. Let me remind you of what I taught you earlier. Elimination method, follow me. Class, according to Boyle's law, the pressure is inversely proportional to volume. Meaning that whatever happens to this guy, the opposite happens to this guy. So if the pressure is reduced to 650, the volume must be increased then. Because pressure and volume don't go in the same line, they are inverse. And even they are directly proportional. Then what happens to this also happens to this. But they are inversely proportional, class. Please follow me carefully. They are inversely proportional. So whatever happens to one, the opposite happens to the other. So if the pressure is reduced to 650, definitely the volume will be increased. Because if pressure is reduced, volume is increased. But if pressure is increased, volume is reduced. Whatever happens here, the opposite happens here. So if the pressure is reduced, I'm now sure that the volume must be increased. Because pressure is inverse to volume, according to Boyle's law. So it means that my volume will be increased. So it means that my final answer must be greater than 300. My final answer must be greater than 300. That automatically eliminates option A. This is my elimination method. That automatically eliminates option A, class. So even if you have forgotten Boyle's law in the exam, option A cannot be an option. And the pressure is reduced to 650. What happens to the volume? Now class, P1, V1 equals to P2, V2. Our P1 is 800 mm mercury. Our V1 is 300 centimeter cube. Our P2 is 650 millimeter mercury. Our V2 is what we are looking for. If P1, V1 equals to P2, V2, let us make V2 straight on the formula. It means that V2 will equal to P1, V1 all over P2. V2 will equal to P1, V1 all over P2. So my V2 is P1. Who is P1? 800. Who is V1? 300. All over P2 is P2, 650. Where's our calculator? So we're going to say 800 multiplied by 300 equals to 240,000. Now divided by 650. I am going to have 369.23. Option B. This is how you solve. Option B. Option B. Please, if you've not gotten it, pause the video and write it in your note again. I have to move forward. I have to move forward. You can pause the video, you can rewind it, anyone. But I have to move forward. You can always catch up with us. It's an online class, so everything I'm doing forward, you can always come and watch it later. Let's take our next question. The pressure of 100 cm cube of oxygen at 35 degrees Celsius is 750 millimeter mercury. What will be the volume of the gas if the pressure is reduced to 100 millimeter mercury without changing the temperature, without changing the temperature. Option A, 850 cm cube. Option B, 750 cm cube. Option C, 650 cm cube. Option D, 580 cm cube. So let us solve the pressure of 100 cm cube of oxygen. The pressure of 100 cm cube of oxygen. So initial volume is 100 cm cube. At 35 degrees Celsius, you must change to Kelvin. T1 is 35. But it said without changing the temperature, let's not waste time changing temperature because temperature is constant. So we're not going to use temperature. Temperature is constant. It means that we're dealing between just pressure and volume. So don't waste your time converting temperature to Kelvin. You will not use it. The pressure of 100 cm cube of oxygen, so V1 is 100 cm cube. at 35 degrees Celsius is 750 millimeter mercury. So pressure P1 is 750 millimeter. What will be the volume of the gas if the pressure is reduced? So my new pressure is now, pressure is reduced to 100 millimeter mercury. Class, don't forget, what will be the volume? So we're looking for final volume, V2. If the temperature, what? Without changing the temperature, temperature does not change. Meaning that temperature is constant. Since temperature is constant, we don't need it for anything. Don't forget, if you go back to your notes, for Boyle's law, temperature is kept constant. For Boyle's law, temperature is kept constant. Class, this is under Boyle's law question. We're just going to say P1 V1 equals to P2 V2. It is clear that the pressure was reduced, so the volume will be increased, class. The pressure was reduced, so the volume will be increased. Because the pressure is reduced to 100 millimeter mercury, the volume will be increased. We have explained why. Pressure and volume are inversely related. So whatever happens to one, the opposite happens to the other. What's my P1? My P1 is 750. My V1 is 100. My P2 is 100. I'm looking for V2. Divide both sides by 100. So the 100 cancels 100 and my V2 is 750. My final volume is 750. My final volume is 750 cm cube. Let's take some Charles' law question as well. Please forgive me for cleaning, but we have a lot of things to do. So please, you can pause the video and then write the solution. Let's go to a question on Charles' law. (28.8 cm cube of nitrogen). 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled to 0 degrees Celsius at constant pressure. Find the new volume of nitrogen. Find the new volume. Find the new volume. Find the new volume. Option A. We have 17.4 cm cube. Option B. 14.7 cm cube. Option C. 27.3 cm cube. Option D. 31.7 cm cube. Class, solution. (28.8 cm cube of nitrogen), that's V1, 28.8 cm cube. V1 is 28.8 cm cube. At 15 degrees Celsius, T1 is 15 degrees Celsius. Convert to Kelvin at 273. You're going to have 288 Kelvin. It's cooled to 0 degrees Celsius, so my final temperature T2 is 0 degrees Celsius. But to Kelvin at 273, you're going to have 273 Kelvin. At constant pressure, find the final volume, V2, we don't know. Charles' law tells us that V1 over T1 equals to V2 over T2. What is my V1? My V1 is 28.8. What's my T1? My T1 is 288. And what's my V2? My V2 we don't know. And what's my T2? My T2 is 273. Cross multiply. So you're going to have 288 times V2. 288 times V2 should be equal to 28.8 times 273. Dividing both sides by 288. But I will make V2 straight of the formula. So 28.8 times 273 divided by 288. Final answer, if you do everything well, you have 27.3 cm cube. Option C, 27.3 cm cube. Notice that I converted my degrees Celsius to Kelvin. Notice that I converted my degrees Celsius to Kelvin. I converted my degrees Celsius to Kelvin. I converted my degrees Celsius to Kelvin. So class, we have done this. If 30 cm cube of a gas if 30 cm cube of a gas at 50 degrees Celsius is warmed to 80 degrees Celsius at a fixed pressure, the fractional increase is option A, 0.009, option B, 0.093, option C, 0.910, option D, 1.090. We're asked to find the fractional increase. If 30 cm cube of a gas at 50 degrees Celsius is warmed to 80 degrees Celsius at a fixed pressure, find the fractional increase. Class, 30 cm cube of a gas means V1 is 30 cm cube. At T1 is 50 degrees Celsius. Is warmed to 80 degrees Celsius, so T2 is 80 degrees Celsius. At a fixed pressure. What is the fractional increase? Class, we're looking for V2 obviously. But it's not just V2 we're looking for. After getting V2, we'll now find the increase, the fractional increase. We'll teach you how to find the fractional increase. Class, convert this to Kelvin. Don't forget, never solve with Celsius. 50 plus 273 will give you 323. 80 plus 273 will give you 353. Always go to Kelvin. Charles' law tells us that V1 over T1 equals V2 over T2. This then implies, what's my V1? 30 cm cube over T1, 323. Equals to V2 is what we are looking for, we don't know. T2 is 353. We'll cross multiply. I'm going to say 323 times V2, 323 V2 equals to 30 times 353. Let's divide both sides by 323. Dividing both sides by 323, we have V2 is now equal to 30 times 353 divided by 323. 30 times 353 divided by 323. You have 32.78. 32.786 cm cube. So my final volume is 32.786 cm cube. But class, if you notice in the option, you will not see 32.786 cm cube. They're asking us to find the what fractional increase. What fraction, by what fraction was the increase occur? They are simply asking us to find the percentage increase. Class, what we are going to do, we're going to look at say 32.786 minus minus the initial volume 30. That will give you 2.786. 32.786, that's V2 minus V1. V2 minus V1, which is what? 32.786 minus 30. That will give you 2.786. So the increase was 2.786. I'm not going to say 2.786, which is the increase, divided by what's the original volume? 30. Divide 2.786 by the original volume to get the fractional increase. How much did they increase by? Divided by 30. So to get fractional increase, slice V2 minus V1 all over the initial volume V1. This is formula for fractional increase. Please take note. So 2.786 divided by 30 will now give you 0.09286. And you can approximate this 8 to make this approximately 0.09. This 8 costs an addition of 1 here. So this 0.93. That is the fractional increase. Please take note. That is the fractional increase. So fractional increase is gotten after getting the new volume first. Find the difference between the new volume and the old volume. You have 2.786. You will now say the difference divided by the original volume, divided by 30. You will now get your fractional increase. You get your fractional increase. Let's keep going, let's keep going, let's keep going. Please don't forget you can easily rewind and watch again. This is how a marathon class works. If you slow down, Jamb will catch us. If we slow down, Jamb will catch us. It is survival of the fittest, survival of the fittest. If we slow down, Jamb will catch us. Jamb is pursuing us. Jamb is just next month, April 16th. If we slow down, Jamb will catch us immediately. But thank God, even if I'm cleaning, it has been recorded permanently, it's not there, it's online. Just rewind and go back again. Rewind, pause, and look at it carefully. What did he actually do? Pause. Sometimes you can pause, look, and go again and again. What is the temperature of a given mass of a gas What is the temperature of a given mass of a gas? Initially 0 degrees Celsius and 9 atm. If the pressure is reduced to 3 atm at constant volume, if the pressure is reduced to 3 atm at constant volume, take A, option A, 91 Kelvin, option B. You can see option is in Kelvin, meaning you have to change this degree Celsius to Kelvin. 182 Kelvin, option C. 273 Kelvin, option D. 819 Kelvin. Class, what is the temperature of a given mass of a gas? So we're looking for the temperature. Initial temperature is already 0 degrees Celsius. Add 273 to convert to Kelvin. You have 273 Kelvin. If the pressure our initial pressure is 9 atm, the pressure is now reduced to 3 atm. Find the new what? Temperature. We're looking for T2. Class, at constant volume means it's Gelusa's pressure law I taught you. Gelusa's pressure law. Gelusa's pressure law tells us that P1 over T1 equals to P2 over T2. What is P1? P1 is 9. What is T1? T1 is 273. What's P2? P2 is 3. What is T2? We don't know. We'll cross multiply. We're going to say 9 times T2, we have 9T2 must be equal to 3 times 2, 7, 3. Dividing both sides by 9 to make T2 set of the formula. 3 here 1, 3 here 3. So our final answer should be 273 divided by 3. And that should give us 91 Kelvin. Option A, 91 Kelvin. Option A, 91 Kelvin. 91 Kelvin. Option A, 91 Kelvin. If you are still with me, say, sir, I'm with you. Please, give me an update. Give me an update. Are you still with me? Say, sir, I can still hear you. I can see the board. If you can still hear me, let me know, please. Someone should let me know. Just drop a comment. I know we are trying to write and catch up, but drop a comment quickly to help me, please. Let me know. If you can still hear me, you can see the board. Let me know. Thank you. Omawumi, thank you. Okay, so I was not wasting my time saying because it's been long I came to the screen to check. It's been long I came to the screen to check. So this your comment matters a lot to me. Thank you. So you are with me. That means you could hear me all those while, right? You could hear me well. Good, good, good. Good, 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 good. Another question. Remember, we're just taking questions now. We're already done with the laws. It's time for question. A sample of gas. Let's go. A sample of gas exerts a pressure of 8.28 cm. A sample of gas exerts a pressure of 8.28 cm. When confined in a 2.93 dm cube container. When confined in a 2.93 dm cube container at 20 degrees Celsius. Find the number of moles. And they gave us R. R is gas constant class. 1Q, you know you are dealing with ideal gas pressure. They'll give you gas constant 0.0821 atm liter per mole per Kelvin. A sample of gas exerts a pressure of 8.2 atm. So my pressure is 8.2 atm. When confined in a 2.93 dm container, volume is 2.93. Volume is 2.93 dm cube. At 20 degrees Celsius, my temperature is 20 degrees Celsius. Convert to Kelvin immediately. Add 273. You have 293 Kelvin. Find the number of moles. Class. PV equals to nRT. Remember, a big gas equation. Solution. PV equals to nRT. I'm looking for number of moles, so let me make n subject to the formula. Divide both sides by RT. I want to make n subject to the formula. RT cancels out, so n is PV over RT. N is pressure times volume all over R, gas constant times T, right? Who is my P? My pressure is in atm, which is okay, 8.2. My volume, 2.93 dm cube is okay. As long as my volume is in dm cube, it's same thing as liter. Remember, liter and dm cube means the same thing. divided by the gas constant 0.0821 and temperature, minus my temperature 293. So let us solve. We're going to have 8.2 multiplied by 2.93 will give us 24.026 divided by 0.0821 multiplied by 293 will give us 24.0553. So 24.026 divided by 24.0553 will give us 0.99878 moles. Class, this is the number of moles. 0.99878 moles. Let me give you small time to write. I know we have been attacking it. This is over 100 minutes of serious intensive class. Over 100 minutes of serious intensive class. If you are still with me, if you have not left, say, sir, I have not left. If you have not left, say, sir, I have not left. I'll give you small time to write. You have tried. Sir, I have not left. Sir, I have not left. If you have not left, let me see your comments. Sir, I have not left. Sir, I have not left. Good. Omowumi said, I have not left. Sir, I have not left. That's very good. That's very good. That's commendable. That is commendable. Sir, I have not left. I'm giving you small time to write. I know I've been increasing the pressure. So take your time and write, then I'll move forward. If you're just joining, say, sir, I'm just joining. Sir, I'm just joining. No, we started early today. If you are just joining, say, sir, I'm just joining. We are giving the students time to write before we fire again. We are giving the students time to write before we fire again. Catch your breath, and let's go. I'm giving you small time to catch your breath, and let's go. You must pass your Jamb this year. You must pass your Jamb this year. You must pass your Jamb this year. If you are done writing, say, sir, I am done writing. If you are done writing, say, sir, I am done writing. If you are done writing, say, sir, I am done writing. Let's take our next question. Let's take our next question. Yes, I gave you enough time to write this one. I gave you enough time to write. I give you more than enough time to write. So let us proceed. 500 cm cube of oxygen was collected over water. Yes, when a gas is collected over water. 500 cm cube of oxygen was collected over water. 500 cm cube of oxygen was collected over water at 30 degrees Celsius and 752 millimeter mercury. What is the volume of dry oxygen? That means without water. You see why we have to know the volume of water from it. Dry oxygen. Dry oxygen means without water. What's the volume of dry oxygen? At STP. I told you what STP means. At standard temperature and pressure. Vapor pressure of water. They give us vapor pressure of water. Is 32 millimeter mercury. Class, this looks like the general gas law question. Because they did not tell us that anybody is constant. 500 cm cube of oxygen. So my initial volume V1 is 500 cm cube. It's collected over water at 30 degrees Celsius. T1 is 30 degrees Celsius. Quickly convert this guy to Kelvin. Add 273. So that you have 303 Kelvin. And 752 millimeter mercury. P1 is 752 millimeter mercury. What is the volume of dry oxygen at STP? So we have V1, we have T1, we have P1. But class, this pressure, since it's collected over water, this is not the actual pressure. You're going to subtract the vapor pressure 32 because we need dry oxygen without water. So subtract the vapor pressure of water 32 from 752. What will you have? You're going to have 720. Class, anytime they say gas collected over water, never use the original pressure until you remove the vapor pressure of water from it. Now we need, they say, what's the volume of dry oxygen? We're looking for V2. Class, what is the volume of dry oxygen at STP? Notice, what is volume of oxygen? But they don't give us, they look for V2. But they didn't give us P2 and T2 because they say at STP. They didn't give us P2, they didn't give us T2. Class, at STP, P pressure is 760 millimeter mercury. And temperature is 273. Class, anytime they mention STP, know that your pressure is 760 and your temperature is what? 273 Kelvin. Please take notes. Please take notes. So we're going to say P1 V1 according to the what? All over T1, general gas law. P1 V1 all over T1 will be equal to P2 V2 over T2. P1 V1 all over T1 equals to P2 V2 all over T2. Notice that we are the one that brought out this P2 and T2. When they say at STP, you should know. At standard temperature and pressure, your pressure is 760, your temperature is 273 Kelvin. Please take notes. So my P1 now we can solve is 720, even if they give us 752, because it's collected over water, we'll minus 32. So P1 is 720, V1 is 500, all over T1, we convert it to Kelvin, 303, equals to P2, what's P2? P2 is 760, P2 is 760 at STP. V2, what's my V2? I don't know. Divided by T2, T2 is 273. Class, we can now make V2 straight of the formula. Let us cross multiply. So that we can say that 760 times 303 times V2 is equal to 720 times 500 times 273. Let's make V2 straight of formula. Divide both sides by 760 times 303. This cancels this, and then we can solve this and get our answer. Calculator is here. We say 720 multiplied by 500 multiplied by 273 will give you 982,80000. Now divided by 760 multiplied by 303 will give you 230,280. Now let's divide 982,80000 divided by 230,280. That will now give you 426.784 centimeter cube. Who got this before I got it? Sir, I got it before you got it. Who got this before I got it? Sir, I got it before you got it. Sir, I got it before you got it. Anybody like that? Sir, I got it before you got it. Let me give you some more time to write. Let me give you some more time to write before we go to the next question. Let me give you some more time to write. Go. People say, I have not left. Sir, I am hearing you. Sir, I have not left. I have not left. I have not left. I have not left. We're almost done. 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 Let's take a question. They said for a gas, the relative molecular mass, for a gas, the relative molecular mass is equal to 2y. What is y? Option A, they said the mass of the gas. No. Option B, they said the vapor density of the gas. Yes. I'll explain why. Option C, they say the volume of the gas. No. Option D, they say temperature of the gas. No. The answer is y is the vapor density of the gas. Remember I told you that vapor density is the relative molecular mass divided by 2. For a gas, the relative molecular mass is equal to 2y. If the relative molecular mass is equal to 2y, if you divide 2y by 2, what will you have? 2 cancels 2 and you have y. And y is the vapor density. Y is the vapor density. Please take notes. Let's take a question under Graham's law of diffusion. Graham's law of diffusion. If 30 cm cube of oxygen diffuses through a porous pot in 7 seconds. If 30 cm cube of oxygen diffuses through a porous pot in 7 seconds, how long will it take 60 cm cube of chlorine to diffuse through the same pot? If the vapor densities of oxygen and chlorine are 16 and 36 respectively, if 30 cm cube of oxygen diffuses through a porous pot in 7 seconds, how long will it take 60 cm cube of chlorine to diffuse through the same pot? If the vapor densities of oxygen and chlorine are 16 and 36 respectively. Class, let us solve this question. So volume of oxygen is 30 cm cube. Time taken for oxygen to diffuse is 7 seconds. Meaning that the rate of diffusion of oxygen, don't forget the rate of diffusion is volume all over time taken to diffuse. Do you remember I told you that? That rate of diffusion is volume divided by time taken for the gas to diffuse. So volume is 30 cm cube. Time taken to diffuse is 7 seconds. Let's find the rate of diffusion for oxygen first. Where is my calculator? Let's find the rate of diffusion for oxygen. Let us find the rate of diffusion for oxygen. So we're going to say 30 divided by 7. That will give us 4.28 cm cube per second. So rate of diffusion for oxygen is 4.28 cm cube per second. But that's not what they're asking us to find, but we need this first. Now how long will it take now? Volume of chlorine is 60 cm cube, right? Because they said how long will it take 60 cm cube of chlorine? So they are saying how long means we are looking for the time taken for chlorine to diffuse. We don't know. But don't worry, so let's first find the rate of diffusion of chlorine and then relate it to time taken to diffuse. We have the density of oxygen and density of chlorine. Density of oxygen, because say the vapor density of oxygen and chlorine are 16 and 36. So density of oxygen is 16, vapor density of chlorine is 36, respectively. Class, don't forget that the rate of diffusion of gas 1 divided by rate of diffusion of gas 2 is equal to square root of the vapor density of gas 2 divided by square root of vapor density of gas 1. So R1 over R2 equals to square root D2 by square root D1. Please take notes. Let oxygen be gas 1 and let chlorine be gas 2. Let oxygen be gas 1 and let chlorine be gas 2. So what is the rate of diffusion of oxygen? Gas 1, 4.28. Rate of chlorine we don't know. Let's call it RCl. Now square root density of gas 2, which is gas 2? Chlorine, 36. All over square root density of gas 1, which is gas 1? Oxygen. So let oxygen be gas 1, right? And let chlorine be gas 2, remember. So density of gas 1 is 16. So we're going to have 4.28 over RCl equals square root of 36 is 6 and square root of 16 is 4. Cross multiplying. Where does that leave us if we cross multiply? We're going to say 6, let's do it here. 6 times RCl is 6 RCl equal to 4.28 times 4. Divide both sides by 6. So say 4.28 times 4 is 17.12. Now divide by 6. It's going to give us 2.853. Class, this is the rate of diffusion of chlorine, but that's not what they asked us to find. Then I said, how long will it take 60 seconds of chlorine to diffuse? But class, if you've got the rate of diffusion of chlorine as 2.853, it's easier to get the time taken for it to diffuse because rate of diffusion of any gas is the volume of the gas divided by the time. Cross multiply, you're going to have what? R times T, RT equals to volume. Now making T square formula divide both side by R. Making T square formula divide both side by R cancels R. So time taken for any gas to diffuse, which they ask us to say how long will it take 60 cm of chlorine to diffuse? Time taken for chlorine to diffuse will be volume of chlorine, which is 60 cm cubed, divided by rate of diffusion of chlorine, which is 2.853. 60 divided by 2.853 will give us time taken for the gas to diffuse. Time taken for gas to diffuse, guys, is 21.03 seconds. This is the time that it will take chlorine to diffuse if it passes through the same pot. That is the time that it will take chlorine to diffuse if it passes through the same pot. 21.03. In our option, we have 21. If you are still here, type we are still here. We have spent over 2 hours in this class. I will soon round up. I don't want this video to be too long. This generation, you guys have a low attention span. Anything that is too long, like people will stop watching. Let me round up. I've touched the major gas laws they usually ask. I have taught the major gas laws they usually ask. Yes. Let's take this question on Dalton's law. Last question for the day. Let's take this question on Dalton's law. And we round up. Let's take this question on Dalton's law of partial pressure. Let's take this question on Dalton's law of partial pressure. If 0.75 mole of cyclopropane, if 0.75 mole of cyclopropane and 0.66 mole of oxygen. Are mixed in a vessel. Are mixed in a vessel. With a total pressure of 0.7 atm. With a total pressure of 0.7 atm. What is the partial pressure of oxygen in the mixture? What is the partial pressure of oxygen in the mixture? They gave us options. Let's look at the options they gave us. Option A, 0.44 atm. Option B, 0.22 atm. Option C, 0.55 atm. Option D, 0.33 atm. Yes, last question for today and we'll round up. If you stay till this time, congratulations, it shows you are really serious, you want to make it. Many people have already registered for this lab, but they are not serious. I've noticed they are not serious. They are considering their data, but when they are on TikTok, they don't remember their data. Class, if 0.75 mole of cyclopropane, let's cyclopropane with gas A, and 0.66 mole of oxygen, let it with gas B. So we have gas A and gas B are mixed. Remember that is law of partial pressure. Says that if there is a mixture of gases, that's where the law started from. That is law of partial pressure. If there is a mixture of gases. So if 0.75 mole of cyclopropane is one gas and 0.66 mole of oxygen, another gas, are mixed in a vessel with a total pressure of 0.7 atm. So total pressure is 0.7 atm. PT 0.7 atm. Class, what is the partial pressure of oxygen? Class, we have oxygen and we have cyclopropane. Let us find total number of moles. Total number of moles of this mixture will be number of moles of gas A plus number of moles of gas B. Remember, they already gave us the total pressure. But they didn't give us the total number of moles, but we can get it. Number of moles of gas A. Gas A is cyclopropane, 0.75 moles. Number of moles of gas B is oxygen, 0.66 moles. So we're going to say 0.75 plus 0.66. That will give you 1.41 mole. Total number of moles, 1.41 mole. Now we have total pressure and we have total number of moles. Class, we are looking for the pressure of oxygen. That's to find what is partial pressure of oxygen. Oxygen is gas B, right? I want to remind you of the formula I gave you that PA over NA equals to PB over NB. Check your notes under Dalton's law. Equals to PC. There's no C in this formula. So it was PC over NC, then equals to PT over NT. But there's no C in this formula. There's only two gases, A and B. We only put C if there's a third gas. But there are only two gases in this particular question. So class, oxygen is gas B and it's the person we are looking for. What is the partial pressure of oxygen in the mixture? So we're not looking for gas A, so we can clean this first part, PA over NA, we can clean it. And take only this one, PB over NB equals to PT over NT. Remember that oxygen is gas B. Pressure of gas B is what we're looking for. Partial pressure of oxygen, gas B, we don't know. So we're looking for PB. We don't know. But do we have the number of moles? MB, number of moles of gas B, oxygen. Number of moles of oxygen is 0.66. Look at the gas B, oxygen. 0.66 mole of oxygen, we have it. So PB all over 0.66 equals to PT, total number of moles 0.7. All over total pressure 0.7, total pressure 0.7. All over total number of moles. What's the total number of moles? We did 1.41. We can now get the partial pressure of oxygen cross multiply. This will give us PB multiplied by 1.41 equals to 0.7 times 0.66. So divide both sides by 1.41. So that PB is 0.7 times 0.66. You have 0.462. Now divided by 1.41. 0.462 divided by 1.41. That will give you 0.3276. 0.3276. If you approximate 0.3276, pick out 0.32. This 7 consolidation of 1 here, so 0.33. Approximately 0.33 ATM, which is D. Which is what? D. Class, if you encounter this kind of problem in Jamb, this is how you solve it. If you encounter this kind of problem in Jamb, this is how you solve it. I hope we have gained something today. I hope we have gained something today. If you stay to the end, let me know if you stay to the end. Tomorrow is day 4. We keep going, we keep going, we keep pushing. We don't stop till we cover the chemistry Jamb syllabus. We don't stop till we cover the chemistry Jamb syllabus. If you stay to the end, congratulations. I would advise you take more questions. Go and look for all questions on gas laws this night. After every night session, don't just go and sleep. Go and look for Jamb question on that topic I taught. Demystify it, break it down, do a lot of past examples. That's why we send you the Jamb Master Pass question. For those that pay completely, you have the Jamb Master Pass question, right? Take each subject, look for gas laws question. Deal with it, deal with it, deal with it. And make sure you are ready for the exam. See you tomorrow for day 4. If you stay to the end, type in the comment section, sir, I was here to the end. Sir, I did not leave. Type in the comment section and let's round up. Well done, class. 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 Yeah, someone says, sir, I enjoy your lesson today. Thank you. Thank you. Thank you. The more we are together, the happier we shall be. The more we are together, the happier we shall be. Yes, yes. See you tomorrow, same time. Although we can start, I will just inform you in the group and we'll start. I just inform you in the group and we start. Good night, everybody. See you tomorrow. Make sure, don't forget, go and study everything I told you, everything we have done today. Take more questions. Test yourself more. Don't be relaxed with just the question I'm giving you on the board. Take more tougher questions. Remember, we have a mock exam after the 30 days challenge. That's when we'll know those that were following and those that were not following. The mock exam will reveal everything. Good night. See you tomorrow, day 4.